So I'm here to talk to you about something that just came up in Yuri's talk, which is that if you start from a monorepo, it's great. It's all awesome. Maybe not entirely. So in this particular case, the company I work for is called Renew Home. And if you haven't heard of us, that's probably to be expected because we have been in business for 189 days. So on April 1st, we formed this company. And as a pretty common case in the world of anything involving software, we're the product of two other entities getting put together. So we come from a background of a product and a program offering that was embedded inside of Google. It's called Nest Renew. It's a product that involved their Nest thermostat and energy optimizations there. And then the company that I worked at, which is called OhmConnect. OhmConnect was a direct consumer energy product. Basically, we got people to reduce their energy usage at important times for the grid and then shared that like earnings back with those individuals. But in this case, these two groups obviously represented two groups of people as well as two ways of working. And as is commonly the case, you got to fit those two together when you come into a new into a new company. But in our particular case, we had kind of a unique problem, which is that we came in with a very clear product mandate. This was not a fit their software into your software sort of thing. Instead, we had a blank slate. And we had a goal that we had to build a clone of this Nest Renew product that was currently running at Google and embedded inside of the Google Home app. We had to make it work without the Google magic. Completely did not get any code to start with. And we had to do this clone build in 91 days because it had to get put into a beta test version of the Google Home app in order to time up with a release of a new piece of hardware that had been being planned and worked on since before Renew Home was even an idea in anybody's head. So that deadline was not going to move, and we had 91 days. I, at this point, was surrounded by people on my team who were all really worried about this deadline and thinking, oh no, how are we possibly going to achieve this goal? And to be honest, I was pretty checked out because the day that we announced the Renew Home merger, my daughter was born. And so I was on paternity leave. I left for a couple months, didn't think about this. But through many long nights of being awake all night and getting no sleep, there's this little thing stuck in the back of my head, and I couldn't let go this idea of a green field. So I'm sitting there one night, in the middle of the night, feeding the baby, and I think to myself, this is an opportunity. This is something that not a lot of people get, to start from scratch and get to make some foundational decisions about how we're going to work, how we're going to build something. And I get stuck on this idea of the greenfield, so much so that I kind of orchestrate my return from parental leave so that I could show up to the meeting where they were like, hey, who's going to deal with what as we get ready to start this new company, because we can't actually write any code, but we can be ready to write code. And so I said, hey, I'll deal with the repo. I'll deal with this. And some background, I used to have my own company, and we used NX there all the way back to 2018. I've used NX in a couple of different companies since, and I really like it. And we had been trying really hard to do this at OhmConnect, and we had a monorepo that was in a subfolder of the main repo, which is a pattern you should not try and replicate. Suffice to say, I was really excited about this opportunity. And so I had to convince some people. Obviously, we had a bunch of people coming from a Google background, and so convincing them that we didn't have a team to manage Blaze was just not a feasible option for us. So eventually, we did it. It worked. We actually implemented NX. We had a team of roughly 35 engineers on day one of the company, and we jumped right into an integrated monorepo approach, which I guess is not really the term anymore now that we have Project Crystal and everything is all just nice. But the idea being that these aren't individual packages. They're all deeply integrated. But the twist here is that as of Friday, when I checked, we have 155 projects in this monorepo, 6 months in, and most of them are written in Python. This is not a story that most people hear when you're talking about NX. There is some TypeScript in there. We have a remix front end, but most of this is in Python. So we did a lot of our own plugin development. We did a lot of things to stitch it together. And I know what you're thinking about at this point. You're sitting here in the audience, you're watching online, you're thinking, wow, what a concise talk. This is great. I'm glad to hear it worked. Awesome. I've got a few questions, but thanks for giving us so much extra time back in our break. Sadly, this is not going to be the case. So one of the problems with the green field is that it's an illusion. It's this idea, it's a philosophical concept, but in reality, this is not a picturesque carpet of green that is just rolling across an uneven surface. This is nature. And when you get closer to nature, you start noticing that it is not the thing you see from a distance, despite this really looking like the Windows XP desktop background. It's not. Which, by the way, that's also a real place, too, I found out. So as you get closer, you discover that you're not the only person in the green field, that there's wildlife. You might run into this guy, a mole. It's really cute and also kind of terrifying. But they dig holes. There's other creatures out there, rabbits digging holes. You can go down those rabbit holes if you want to. But the point is that you can't just frolic carefree, footloose and fancy-free across this field, building anything you want. You are probably going to step in a couple of holes. And especially if you're sprinting really fast, those holes can become a problem. So what are a couple of those that we ran into? First one is names. Now, maybe this is incredibly obvious to some people, and I just hadn't come to this realization until very recently. Names are the only fundamental resource in a monorepo that you have to share with everybody. You can have so many teams working in a monorepo together, and they can all have their own little wedge, and their projects interact with each other, but they're isolated parts of the graph. But fundamentally, the names you assign to those projects are shared across everyone who works in it. So you should really take a little bit of extra time to name things, because this is all complicated by the fact that naming things well is not a trivial task. We all have experience with this. This is why it's nice to be able to move a project in the monorepo. But getting that name set correctly the first time is not easy. But on the other hand, getting consensus around what you call a thing is crucial, because that's how you work with other people. Someone has to look at the thing and at least have some semblance of an idea of what it is. Otherwise, they're going to spend a lot of time figuring out where things are. So for our team, we found that this was so crucial that we set up a process. And I know like 10% of you just cringed inwardly thinking, oh no, another committee. Somebody is going to have to arbitrate all of the names, and we're gonna have to go to a meeting to get a name approval. And that was really a big fear for us. So much so that we decided to implement a completely different process, and we have kind of leaned into this to the point where it's actually really, really efficient now. So the first thing that we set as a value for this process is it has to be low friction. You have to be able to be a self-serve, and it has to be very self-explanatory. So in our case, we picked a Slack workflow, which if you've never used those, it's kind of a cool feature they have. But you can click a button in Slack, and it pops up a form, and it has 3 fields. You got to give us the project name, the path where you're going to store the thing, and then you got to tell us, is it an app, is it a library, or a plugin? And with that, it makes a Slack post in a standardized format, and we have a conversation in the thread. Anybody who wants to have any opinion about what we call a project in our repo, or naming in general, our channel is called engineering naming, literally, you join that channel, and then it posts at here for every one of those messages. So you go in, if you happen to be around, you don't like a name that somebody has just proposed, you put something else in the thread. And the key there is you have to contribute something productive, right? You can't just be no. It can be no and, or no however. So no matter what, though, we have some amount of conversation, and what you're looking for at the end is consensus from ideally 2 sources. At least one person who is in the context of what you're doing, somebody who's on your team, who knows what the thing is and agrees, like, yeah, this is a good thing to name it. And someone who is as far as you could possibly imagine from your context as well. So find someone from the data analytics team that is not working in anywhere in the product space, and they should be able to look at this and say, like, yeah, that also makes sense. I wouldn't be confused by that name. Now, sometimes it's hard to find those people if it's off hours or something like that. So we don't always meet that goal, but that's the ideal. And the last thing is that we isolate project generation. This is one of the only places where we routinely use code gen inside of our repo right now. And the biggest problem we've had is that if you generate a new NX project, you end up with a bunch of boilerplate files that probably don't have a lot of meaning to a code reviewer. If you've run the generator should have done its job of making the code reliably. And so what we try and do is we sandbox that run of a single NX command into a PR. We link the NX naming thread so that you can say, like, this is what we agreed on the name to be. We put a copy of the NXG command in there so you can see this is the command I ran. I intended it with the right name in there. And then a code reviewer simply spot checks a couple places to make sure that things ended up in the right folder and that it's got the right name. And that's a pretty easy PR to review, as opposed to if I had generated a project and then wrote 4 or 5 files of logic inside of there, now somebody really feels the need to review every file in that PR, which might be 10, 12, 16 files, depending on what your code generation looks like. So we're trying to isolate the things that are automatic so that review goes really, really quickly. The benefit of that is you get names into the repo as quickly as possible. You don't want a PR where you agree on the name to then take a week and a half to show up in everybody else's environment, because that increases the likelihood for naming conflicts, especially when you're working as fast as we were. Early on, we were getting 2, 3, 4, 5 new projects in the repo every day in order to get as fast as we were going. All of this is in service of avoiding moving projects. And now we just heard from Yuri, who's talking about sometimes you have to move things and it should be really fast. But ultimately, we've decided it's actually a bigger problem to move projects than it is to take the time to name them well up front. Because not only are some languages difficult to move, remember we're writing a lot of this in Python, and our Python plugin does not implement move at the Python level. I can move the NX project containing Python, and I can fix a few things about that, but I can't rewrite the Python code currently because we haven't invested the time to do AST parsing and completely refactor Python code. but it also increases the likelihood for Git conflicts. If you're moving big chunks of your repo around, you're probably going to create a merge conflict with somebody else, and resolving that just is more overhead for the developers. And at the end of the day, developer confusion slows you down, right? The more you confuse the people working on the code base, the less you're actually getting work done. Second thing is NX boilerplate and copy pasta. So I mentioned we had a number of engineers that came from the Google background. They really wanted Blaze because they were really comfortable with it, and we had to kind of work through what some of the differences were. But one of the main pieces of feedback that we heard over and over again is that when I make a new NX project, I end up with a lot of boilerplate. It feels like there's a lot of files going on in here as opposed to like having one build file that sort of centralizes all of that. Now the number of files ended up not really being the problem. We kind of narrowed it down to kind of a specific result of having duplication, and that was, give you an example. So say I start a new app, I make a little Python server, and I've set it up, but our code generation is just I have a Python project. So it sets up a Python project for me, and meanwhile I go write some code and have a server that I can spin up, and I make my own serve target at that point because we don't have a generator that's specifically about a fast API server. So I make my own serve target, and it works great for my purposes. And then a few weeks later, another team's like, hey, we're building a Python server. Kyle has a serve target over there. We're just going to go steal his serve target, and we're going to put it in ours. So they've now copy-pasted that thing across. Keep in mind, this is also true if I had a generator that did this in both places. Because while they're working on their thing that I don't know that they copied, I go in and add a debug target to my serve target. Now I can debug my running server. This is super convenient. It's a really great convenience thing that I built, and I want to use this everywhere. So then I end up helping them with something on their project. I see their serve target, I try and run it with debug, and it doesn't work. So now I have to go copy-paste that thing over. Even if I had a generator making that target, improvements to the generator, I would have to also go make a migration to migrate everybody's targets. That's just problematic. You end up getting these pieces of the repo that are kind of out of the way, you don't necessarily see them, and you don't have a really good way to keep them up to date. And once you go from a few targets to, you got 10 targets in every project and you've got 150 projects, you have a lot of pieces to go maintain. So what we end up solving that with is plugins. Now, there's some extra stuff that NX has just released that also negates the need for a little bit of what we've built ourselves. But at the end of the day, we found that the stuff that was developed for Project Crystal of task inference is incredibly valuable. We've leaned into a system where we infer the types of projects. So for example, all of our Python projects have the same test target. We enforce how we do code coverage, we enforce how we do debugging so that nobody has to go and figure out how to do that. An addition on top of that would be like if we had NX conformance, we could then go ensure that everybody is using that inferred test target and they're not overwriting it locally. But that is incredibly valuable from a place of centralizing that logic, right? You don't have this chance of somebody taking a target, borrowing it, and putting it in another project and not realizing that they've missed capturing half of their test files because they configured the target slightly wrong. The other side of that is if you're going to lean into plugins, you have to make it easy for people to add to those plugins. It can be kind of confusing if you're not used to working in NX. Well, I've got this thing that I want to do sort of across all the projects in my repo. Where do I put it, right? It's the same problem that you have of naming a thing, but it's more like, hey, I need to write a new generator. Should I also write a new plugin to store that generator inside of? And you're trying to keep things from scattering out to the wind. So we ended up developing kind of a 2-layer strata that fits in with one of the earlier presentations of sort of the 3 domains in which you can store things. And for us, it was really about language implementation. So like specifically, are you working in Python, or specifically, are you working in TypeScript? Or on top of that, like kind of the next layer of abstraction is there a framework associated with it? So we have a Python plugin, but we also have a CDK Python plugin that deals with things that are specific to CDK, but Python plugin may provide some utilities that are imported up into the framework layer so that we're kind of sharing all of that logic around. The third thing is dependency structuring. This is a topic that necessitates its entire own presentation, so I'm not going to go into it super deep, but there was a couple of kind of dangerous patterns that we discovered and a couple of ways that we found to kind of avoid them. So the really important educational component is knowing where and when to cut things apart. How do you do surgery on a project that you built really, really quickly? For example, we end up writing things where we'll make an app, and we're going to just spin it up as quickly as possible. We end up writing a lot of business logic inside of there, and then eventually we come back to it and say, like, this app has gotten a little too big, or hey, we want to share this thing between 2 apps, or an app and a library, and so that necessitates going in and cutting that piece out, lifting it out into a library. And that's sort of the textbook case for having a dependency tree, right? I want to depend on this thing in 2 places. There's a couple of other reasons you might want to cut things apart. You might want to isolate low change code or slow testing code. That might be a reason, you might do that just for optimizing CI, but you might also do that for making dependencies simpler. You might want to actually move some of this off into a corner so it's clear that this chunk of logic actually really only has one dependency, and that should be the only reason it changes. If you end up with business logic libraries where you're collecting a lot of things together, you have a tendency to build kind of a dangerous pattern here, and that's what we call the hourglass dependency pattern, where like that thing that's in the middle could be, it could be a business logic library, it might be your database access library, but it's a thing where ultimately everybody ends up depending on it, and so therefore everybody depends on all of its dependencies. And you don't so much have a graph as just like a bunch of lines that all cut through the same point. And so that in itself creates a problem for dead code elimination when you're in a language like Python that can't actually tree shake. So we had this with our Python libraries where we actually had a dependency on a single database access library, and it had a pattern, it had all the patterns for accessing all of our tables in Postgres, and we ended up having to slice the thing apart vertically because ultimately, if you needed anything in the database, you were pulling in all of the database patterns and you were pulling in all of the dependencies of that library, even if you really only needed a tiny sliver of it. So figuring out places to cut vertically was an improvement for us when we didn't have dead code elimination. Now, all of this sort of loops back around to the idea of the green field, which is that we've now figured out where some of these little trip hazards are. We know, because we've sprinted through this field, that these are things we have to watch out for. But this is only valuable if you're the person who's run across that field. You have to make sure that you have some artifact, something that tells people who come after you, hey, don't go that way, go this way, right? And so what we've realized is there's a few fundamentals that make that knowledge part of not just your team's culture, but also build it into the code base itself and the way developers use the repo. First of all is that you have to make things convenient. You have to make things low friction, self-serve, and on-demand, right? You can't have a committee that meets once a week to approve names because you're going to slow down the rate at which you can add things to your repo. You should document things. We should all document everything, right, if we had the time. But more importantly is with conventions, document why they exist, not just that they exist. Once your team has discovered, like, hey, we're doing this thing, we're naming things, and we use these suffixes on our project names to indicate end-to-end, and these are APIs or whatever, give some reason as to why you ended up there so that someone who's completely new and doesn't have all that context comes in and learns the reasoning that got you to that answer so that when there's something that doesn't quite fit in there, they can make a decision that puts them in the realm of possible rightness, and they're not just guessing like, oh, we have these three things, I'll just make a fourth one, and I don't see any reason why we couldn't have a fourth. And ultimately, that's all in service of solving problems before they come up, right? You want people to make the right decision so that you're avoiding scattering to the wind there. This leads into documentation maintenance, right? You have to invest time and energy into documentation, but written documentation is fine. Code as documentation is better. And we talk about that, people say like, code is documentation. Like, this is true, you should go read the code. But what I'm talking about here is code that runs inside your repo. Automating things in your repo as a way to document how to do them is a better long-term solution than expecting people to find a README or something in a wiki that explains, oh, well, when you're making a new project, you should do this. Because the likelihood that somebody who onboards a year from now finds that and reads it before they do the thing is pretty low. But if you've got a tool that does the thing and you can intervene at that moment and prevent them from doing the wrong thing in the first place, you improve the likelihood that your repo doesn't end up in a bad state. The last piece of this is that everyone has their own day one. So we had the opportunity of having a monorepo on day one with a bunch of engineers and showing up in a completely new company. But since then, we've hired more engineers. We're growing. We're trying to make a bigger team. You have to remember that everybody is going to have a day one with this thing. And so it will be their first day with it, and they are not going to have any idea what they're going through. So in our case, when I was setting up the repo on day like -10 sort of to the company and I was getting things ready, I also built the presentation for our onboarding class to get people into that. And that one presentation is a living document. So once somebody goes through that class, we encourage them to then go and comment in the Google Doc or in the Google Slides or go and actually just edit it, add a new slide, add some new content for something that didn't make sense to them. Because if you're the person who's joining the company, the one superpower you have is the thing that nobody else can recreate inside the company, and that is fresh eyes. You have the context of never having seen any of this before and being able to point out, like, this doesn't make any sense. I have no idea what you're talking about here. And so encouraging everybody as they walk in the door to make their first contributions be a thing that makes it easier for the person that comes after them, they're the only person that can effectively do that. And encouraging that culture of building a process and refining it from day one leads to improving things like your naming process, right? You don't want these things to become crusty and immovable. You want them to be mobile and they move with your team as you develop new processes, right? You want these things to evolve along with you. Otherwise, you're just going to leave them in the dust. They're going to become useless, and people are going to ignore them. Ultimately, all this boils down to making the right decision the easy decision. For any developer, whether they're the most seasoned, distinguished engineer or the juniorest person who just joined the team, you want them to have the agency to make decisions and work on the products because that's why you've hired them. You don't want to be sitting over their shoulder the entire time. But you want to make sure that they're not making the wrong decision, right? You don't have to course correct them every 5 minutes. Now, maybe with junior engineers, you're doing more education, but the idea is that the tooling that you put inside your repo that developers have to touch every day should encourage the right decision with the least amount of friction for them. And that's all I've got. And so I did hopefully make good on my promise that we would have a little extra time to go out on a break. So came in a little under time. I'm glad to talk about any of these topics. In particular, if you are using Python in an NX monorepo, I would love to talk to you because I have not found anybody else who is doing it the way we are. And suffice to say, we did consider Bazel. We've had some conversations about that. So would love to hear more. If you're working in any of these spaces or anything that sort of overlaps with it, love to hear your experience as well. Thanks, everybody.